the computer hunched over all day. And so we can all get back to what we want to do, right? Which is enjoying life. So just to talk a little bit more in depth about what could some benefits of automating something be and what could drawbacks be, because we all want to focus on the benefits, right? But we have to look at what the cons are in a situation in order to address them and to manage them. But some of the benefits we found in looking at some of the automation currently in construction is it can increase efficiency, right? A robot can run the same thing all day long over and over again. Machines don't typically make mistakes. They don't get hungry. They don't get tired. They don't have bad days. Maybe they do, and we just don't know about it. We also have seen increased labor productivity when you give somebody a better tool, a faster tool, then they can typically work faster. It removes repetitive work processes, and I know that we've all seen this if you've spent any time in the field, building construction projects or watching people work. Just imagine swinging a hammer and doing the same movement day after day after day, and the stress that puts on a body. I'm really passionate about that particular item. My dad is a carpenter. I grew up around projects my whole life. My dad did home building for a long time. And I remember going to the site, wearing my bags and my hammer to try to help him. Of course, little kid. Back in that day, OSHA wasn't so strict, I guess. And he's now 65 and his shoulders are just wrecked. They're completely wrecked from all the work he did. And, if he tries to do anything like wakeboarding behind the boat, his shoulders pop out almost immediately. And that's from repetitive stress injuries. And that's a really common occurrence in our industry. On top of that, automation can shorten schedules, and it also can collect data faster in certain cases and analyze the data faster so we can make decisions faster on our projects. If there's something going wrong, we might be able to be informed faster to make a decision to change and alter that course of a project. So those are some of the benefits, some of the drawbacks. So one of the big things I often hear is the cost of investment, this cost of development. And yes, a lot of things, especially if they involve technology, if you think about robotics, it can become very expensive. But that's when you really have to analyze, if I were to develop this, can I gain my money back in X number of times? Is there enough labor productivity increase? Is there enough schedule savings? So you really have to look at that and determine if it is. Another alternative is to partner with people in order to develop items. Cost and time of implementation is always a factor in anything new. And then a big thing is actually, which is kind of contradictory to the earlier statements, is a loss of human interaction in decision making. So that first piece I really attribute more to kind of mental health. And if your coworker becomes a robot and it's no longer another human, that changes your job environment. It changes the way that you interact with your environment at work. And that can have impact on employees in a different way than helping their body not get as hurt. So there's some of that. Also, humans play a key role in the actual decision making. Think about, a smart driving car, and is it really making a true decision whether to avoid hitting that person in that, crosswalk? Or are we programming it to do that? And what is the implication of that? I don't have any of those answers, by the way, but it's just an example that comes to my mind. I read a few studies on it, and I find it truly fascinating that in order to program something to be quote unquote smart, we actually are literally taking our own human decision making and we're trying to tell a machine what decisions to make in that particular instance. So it's just something to think about. And then with any type of system, machinery, robotics, even computer software, you have maintenance to do. So how do you monitor and maintain those systems going forward? And the investment and cost of those items is really important to consider as well. So now I'm going to run through a couple of examples. I just picked a few, most of them are task oriented, but one of them is not. It's related to data collection. So the first one is a tool our innovations department built. It's to help put fasteners into mass timber decks. Just imagine these guys or ladies on a deck with 18-inch bearing screws. They're trying to drill into a deck. It's pretty arduous work. A lot of them complain about back and shoulder pain. 6 hours doing this all day long. They also burn through drills pretty fast. So we made this machine. Press a button, and it loads in the screws and it drops them down this tube and it automatically drives up to 4 of them at a time. So it's doing the work of 4 people. It still requires an operator and human interaction. There's still someone there, and there is still some decision making involved, but we've definitely increased our production and provided a better quality of work. The next item, this is a startup company we've worked with for about a year. This is the Dusty Robotics layout robot. If you've ever seen people do layout, and I remember seeing, of course, my dad doing layout, and it's snapping lines with chalk everywhere and bending over and making measurements and correcting measurements all the time, and it can be tedious. So with this, you take your CAD model, you make sure everything that you want printed on the ground is in there, and with a total station that this robot talks to, it goes out and it prints your layout on the ground for you. Again, there is still some human involvement. It involves, an operator to be there to manage the computer and the total station and to keep an eye on it. But it can do a lot of work with limited backbreaking work. Again, it's nobody's, running around on the ground trying to do layout. This is a great solution. We've been working with them for, like I said, about a year, and they're also a woman-owned business, which I love about them. This next one is another task-oriented item. It's called the TieBot, rebar tie robot. We've never used this here at Swinerton, but I love it. And it's literally a robot that you mount. It's a system that's mounted, and it runs across the rebar mat, and it locates rebar sections. It doesn't have to be pre-programmed. And as it comes across an intersection of rebar, it automatically reaches down and ties the section. It can work in the dark, so you can have this running all night long if you need to. And you don't have to risk your employees walking all over these rebar mats and rolling an ankle or hurting a leg. This last one is not specifically task oriented. This is the CraneView. It's a versatile CraneView system. It's a IoT devices that hangs underneath the hook of a crane. And as this device hangs there throughout the day and the crane is working, it collects a variety of information. And from that information that it's collecting, it can then analyze and report with productivity, crane usage, real-time alerts, safety alerts, and then it produces these awesome reports that can help you do things like reducing your cycle times of your concrete pours even. We've again worked with this company for about a year and a half now, and another wonderfully woman-owned business startup in the construction industry. And a lot of great insights can be found using this automated data collection means. So a recent project of Swinerton's, also in the data collection realm, was we took a spot dog robot. We actually had 2 of them. We called them PE 2.0 and Apprentice. It was kind of an internal joke. We let the whole company vote on their names. And we had Spot semi-autonomously go through a building and collect data for us. So what the data we were collecting was we were collecting 360 photos. We were collecting LiDAR scans, creating point clouds of the building. And then we also had an environmental sensor where we were collecting different environmental data wherever the robot walked. The great thing about Spot right now is that you can program its path for it to walk, and it can remember that path. So then the next day you come in, you press a button, and Spot will simply go out, and whatever payload you put on it and programmed, it will automatically then collect that data and walk the path you want it to. There's also newer functionality that allows you to teleoperate it. So not fully automated solution there, but it allows you to collect data from the comfort of your own desk potentially. This is some examples of some of what we did with the data we collected off of Spot. We took the point cloud models and the photos that we collected, compared it against the BIM model. And from that, at any given point in time, we could tell you the quantity of work put in place against the schedule of values. And that then could tell us the percentage of current progress as well. With that being said, we worked with a PhD student at Stanford who also developed a system of taking that same information and using it to update the P6 schedule. Again, this was all automated processes that we were developing. And while we were still in the pilot phase, there's definitely room for this to become a full implemented project at some point. This is just another slide showing the progress chart that was created and updated weekly for us with these automatically collected point clouds and photos. And on the right, you can see if you cost load your model, you can also load this information into your schedule of values and automatically create your own payment application. And this payment application is created with facts, not a person walking around pointing, counting things, and making guesses of what's really there. So if you have interest in looking to automate something, or you're like, hey, I've seen people in the field doing the same thing over and over and over again, it just doesn't look comfortable, it looks like it would hurt, maybe there's room for that to be automated. And some of the things that I ask myself when I'm thinking about that is, will there be an increase in production? Will the quality or the quantity of what they're doing increase if we automate it? Also, if we automate something, can it empower our employees to perform their work better, easier, faster? And what are those factors that I need to look at to determine the ROI of a potential project to automate something? So on the bottom line of the slide, what I did is I laid out kind of the steps that you would need to start in investigating into automation all the way through fully implementing an automated process. At first, you want to define your scope, right? You want to figure out what do I want to do? And that can change over time too. You might start with one idea, and as you ask questions, as you talk to the folks in the field, as you talk to your admin staff or your PM or your PX, you'll start to understand really what the problem is, and maybe it's not quite what you thought it was. And that's important to just shift your thinking there and maybe change your engagement with what you thought you wanted to automate. From there, you define and test your tool selection. So this could be building your own tool, building your own piece of software, writing your own algorithm. So many different solutions here could come to mind. There may be some that already exist, or it could be actually building something entirely new. Of course, I get super excited about building things that are entirely new, but again, that investment there could be pretty high. So there has to be a pretty decent ROI to go down that road. From there, the best thing is to develop a small pilot. You don't want to just, let's change the whole process and put all of our money into it. Just take one piece of it. So for instance, with Spot, the robot dog, we said, can we make it walk the same path in 200 square feet or so repetitively for a few days? And once we proved that we could do that, can we have it do a whole floor of a building? Then when we prove that, can we do the whole building? So even within that test and pilot phase, we did several of those to really prove that this was something we could continue to do as we scaled it up. And eventually, the idea would be to scale that into a full-blown deployment for multiple projects. The testing and the actual executing of the test pilot and analyzing the results, a big piece of what I do here is I really spend some time talking to the people who would be what I would call the end user. Find out, do they like it? Do they like the solution? What do they want changed on it? There could be something you hadn't even thought of. I remember testing exoskeletons, and we had a couple of our workers put them on, and he was trying to, I think, hammer overhead. And I remember he was trying to reach for his hammer, and just the simple fact that he now had to reach further around this exoskeleton to grab his hammer where he always kept it. And we're talking somebody who's been working 17 years in the industry. The fact that he had to then change the way that he was reaching for that hammer actually was causing his arm to hurt more. So what we sometimes think is a good idea isn't always what the people need to perform their task. And it's important to get their feedback and information, especially as you get deeper into creating a customized solution. That was actually a fantastic particular test, and we ended up not using exoskeletons on that particular project for those specific reasons. From here, from after you do your analyzing your results, you want to try to develop some type of scalable automation. It could be a project, you could go for a full region. I wouldn't necessarily jump right into let's go company wide, depending on how big your company is, and then slowly scale that out. I would definitely get a solid implementation plan and training plan down, get training documentation. Right now, with so much technology, right, we can make videos to help people, audios. I wouldn't recommend TikTok it, but do a couple YouTube videos, share them with the people that are going to be using, write your own manual. It's really not too bad. And then make sure that's accessible information to whomever is going to be using the future automated tool or process. And then from there, you have to develop a maintenance plan. Like if we were to have a bunch of spot dogs running around on all these projects, we're going to want to check their batteries, make sure their pieces and parts are moving, their scanners are scanning correctly. So there's always got to be some type of maintenance to move forward. Even with software, there's maintenance that's involved in that. And I'm sure also as you continue to implement it company wide, potentially you probably want to expand it as well. So you might want to be continue to upgrade and change it and things like that. So that's always a part of that roadmap and plan. Um, so that's really all I wanted to share today about automating. I think that in a lot of ways it can be super useful. I know that there's always going to be areas of work that it's not going to be the answer. It can actually make people's jobs harder, but that's where it's really important to get in the field, get out into your offices, and really have the conversations with your employees that need to be had to find out, what they know. Because everybody at every level in your company is going to have information that you maybe don't have that could help inform your potential to test out automating a process or a task. So I've included my email address here. Anyone's welcome to email